So this is one of the homework problems. There you have a function defined as a function g of x. It's defined as a piecewise function 3x minus 1 for the interval where x is greater than 1 and x cubed minus 2x plus 3 for the interval where x is less than or equal to 1. You have to check the differentiability at x equals 1. As with any other differentiability problem, the very first step is to check the continuity. So let's go ahead and do that. We need to check the continuity of this function within a neighborhood of x equals 1. In order to check the continuity, we have to calculate the left-hand limit as x approaches to 1 from left-hand side g of x, and the right-hand limit, which is as x approaches to 1 from right-hand side g of x, and also we have to evaluate the value of the function at x equals 1. If those three pieces are equal to one another, then we conclude that the function is continuous within a neighborhood of x equals 1. If so, we continue into the next step of calculating the right-hand differentiability and the left-hand differentiability. However, if the function is not continuous, we need to stop right away. Let me first go ahead and calculate the left-hand limit, which is the limit as x approaches to 1 from left-hand side g of x. X approaches to 1 from left-hand side means x is very close to 1, that's true, but x is less than 1. When x is less than or equal to 1, we have to use this function x cubed minus 2x plus 3. So let's go ahead and use that function, limit x approaches to 1 from left-hand side. The function is x cubed minus 2x plus 3. When I do the direct substitution, I get 1 minus 2 plus 3, which is equal to 2. And then I will calculate the right-hand limit, which is the limit as x approaches to 1 from right-hand side g of x. This is equal to limit as x approaches to 1 from right-hand side. What component function should be selected? When x is approaching to 1 from right-hand side means x is very, very close to 1, that's true, but x is greater than 1. When x is greater than 1, g of x is equal to 3x minus 1. So let's go ahead and use that function, 3x minus 1. We can do the direct substitution straightforward. It's going to be 3 times 1 minus 1, which is also equal to 2. So as per these two results, we can see that the limit exists as x approaches to 1. But that's not enough. We also have to check the value of the function at x equals 1. So let's do that, which is g of 1. The equality is defined with this component of the function, x cubed minus 2x plus 3. So I need to substitute 1 for that. Then it's going to be 1 cubed minus 2 times 1 plus 3. This also simplifies to become equal to 2. These three components are equal to one another. Therefore, you can conclude that this function is continuous within a neighborhood of x equals 1. You have to write it explicitly in words, and then we can proceed to the next step. So the next step is to check the differentiability. In order to check the differentiability, we have to calculate two components, the right-hand differentiability and the left-hand differentiability. We have to calculate both of them at x equals 1. So let's first go ahead and write down the equation for the right-hand differentiability. It's always advisable that you always write down these equations, the generic equations, and then you can substitute the given values of that specific question and solve the problem. However, until you remember these equations, please always write down that initial generic equation. We know that d plus at x equals h is equal to limit as delta x approaches to 0. On the numerator, we have f of h plus delta x minus f of h, all of that divided by delta x. That is if the function is given in terms of f. This function for us is given in terms of g, and this value h is equal to 1. Therefore, we have to do some modifications when we write down this equation for our problem. We will write it as d plus as x equals 1. I will write this as limit delta x approaches to 0. On the numerator, we will have g. Instead of h, it's going to be a 1 plus delta x minus g of 1. In the denominator, we have delta x. This is equal to limit delta x approaches to 0. On the numerator, the first term is g of 1 plus delta x. When we say 1 plus delta x is greater than 1. When x is greater than 1, what's our function? This is the definition of g of x. When x is greater than 1, the function g of x is equal to 3x minus 1. What we need is g of 1 plus delta x. Therefore, I have to substitute 1 plus delta x for x in that function. Then it becomes 3 times 1 plus delta x minus 1. So let's go ahead and write it down. On the numerator, I will have 3 times 1 plus delta x minus 1. And then I need to subtract g of 1 minus, what is g of 1? We have to see what's the function when x is equal to 1. When x is less than or equal to 1, g of x is equal to x cubed minus 2x plus 3. Therefore, in order to find g of 1, I have to use that function. I simply have to substitute 1. Then I get 1 cubed minus 2 times 1 plus 3, which simplifies to become equal to 2. Therefore, we need to subtract 2 as g of 1. In the denominator, I have a delta x. Now we need to do the simplification. This is equal to limit delta x approaches to 0. On the numerator, you can see 3 times 1 is going to be equal to 3. That minus 1 minus 2 will be 0. There will be no constant on the numerator. The only term we have is 3 times delta x. We have 3 times delta x on the numerator, and we have a delta x term on the denominator. Now we can do the simplification. We can cancel off the delta x and the delta x from the numerator and the denominator respectively. We can do that thing because delta x is not equal to 0. Therefore, this answer is equal to 3. That's the right-hand differentiability at x equals 1. That's not enough. We also have to find the left-hand differentiability at x equals 1. So let's go ahead and write down the equation for the left-hand differentiability. The generic equation is d minus as x equals h. We have limit delta x approaches to 0, f of h minus f of h minus delta x, all of that divided by delta x. We have to do some modifications for this one once again. This h is going to be equal to 1 for our problem, and the function is given as a g. Therefore, let me write it down. D minus as x equals 1. This is equal to limit as delta x approaches to 0. On the numerator, the first term should be g of 1 because our h is equal to 1 minus g of 1 minus delta x. All of that has to be divided by delta x. This is equal to limit delta x approaches to 0. On the numerator, we need g of 1. As we saw earlier, g of 1 is equal to 2. One small additional advice. Whenever you apply this left side differentiability, the term that has to be subtracted on the numerator is f of h minus delta x. Therefore, it's always advisable that you write it down inside big brackets, because for most of the cases, it'll have more than one component. And you have to distribute this negative symbol into each of those components. So it's always advisable that you write down that second function inside big brackets. So let me do it as that. Minus, I will open bracket, and then I need g of 1 minus delta x. When we have 1 minus delta x is less than 1. When x is less than 1, our function is equal to x cubed minus 2 times x plus 3. Therefore, we need to substitute 1 minus delta x for x of that function. Then it becomes 1 minus delta x, everything raised to the third power, minus 2 times 1 minus delta x plus 3. So let's go ahead and write it down. We will have 1 minus delta x raised to the third power minus 2 times 1 minus delta x plus 3. I will close the brackets. In the bottom, I have a delta x term. Simplifying this may be somewhat difficult for some people who are not having a strong college algebra background. That is because of this term, 1 minus delta x raised to the third power. But it's not very difficult if you can remember an identity from college algebra. What's the expansion of a minus b raised to the third power? We know this is equal to a cubed minus 3 times a squared times b plus 3 times ab squared minus b cubed. I'm going to go ahead and use that result in order to expand 1 minus delta x raised to the third power. In that case, a equals 1 and b equals delta x. Now this is equal to limit delta x approaches to 0. On the numerator, the first term is a 2 minus, and then I need to open big brackets. Inside the big brackets, I need to expand 1 minus delta x raised to the third power. That will be 1 raised to the third power minus 3 times 1 raised to the second power times delta x, which is just 3 times delta x, plus 3 times 1 times delta x raised to the second power, which is 3 delta x squared, minus delta x raised to the third power, minus delta x cubed. And then I need to distribute this negative 2 to each of the two terms inside this parenthesis. Then I get negative 2 plus 2 times delta x. And finally, I have a plus 3. We'll close the brackets, and in the denominator, I have a delta x term. Now we need to simplify this numerator, and then we can evaluate this limit quite easily. This is equal to limit as delta x approaches to 0. On the numerator, if I look at the terms inside the brackets, here I have a 1, here I have a minus 2, and here I have a 3. Those terms will be simplified to become a positive 2 inside the brackets. But I have to distribute this negative symbol from outside, so it will become a negative 2, and that will be simplified with the 2 here to become 0 for the constants. And then I can look at the other terms. If I look at the first order delta x terms, I have negative 3 delta x right here, and I have positive 2 delta x right here. Those two will simplify to become negative delta x inside brackets, and then I have to distribute this negative symbol. Then it becomes a positive delta x term on the numerator. And then I have just one second order delta x term right here, positive 3 delta x squared. When I distribute this negative symbol, it becomes minus 3 delta x squared. And in addition to that, I have a third order delta x term as a negative term inside brackets. When I distribute this negative symbol, it becomes a positive delta x cubed term. In the denominator, I have a first order delta x. On the numerator, we can factor out a delta x. So let's go ahead and do that. Limit delta x approaches to 0. From the numerator, if I factor out a delta x, I will have 1 minus 3 times delta x plus delta x squared. In the denominator, I have a delta x. Now we can do the simplifications. The delta x's can be simplified, and we can do that because delta x is not equal to 0. Now, the next step is very straightforward. You need to simply go ahead and substitute the value of delta x equals 0, and then you will see the answer for the left-hand differentiability. Since we have finished calculating the left-hand differentiability and previously we calculated the right-hand differentiability, if those two are equal, then we conclude that the function g of x is differentiable at x equals 1. If those two are not equal to one another, then we conclude that this function is not differentiable at x equals 1. Even though I completely answered the right-hand differentiability, I didn't complete the left-hand differentiability. It's very simple. You just have to go ahead and substitute 0 for delta x afterwards, and then you can compare those two answers for the left-hand and right-hand differentiability and write down your final answer, whether it's differentiable or not. All right, so I'm going to stop this video at this point. Thanks.